Okay, so this last section, we are now at page 10, is on the dispersion of white light. So what is dispersion? Ordinary light or white light is actually a mixture of different colors of light. So this is what we call the visible light spectrum. There's actually a few different type of lights that we can see. Red, orange, yellow, green, blue, indigo, violet. So this is what we say the colors of the rainbow. In fact, a rainbow occurs because there's dispersion of white light with the water molecules in the air, water droplets in the air. So when a beam of white light passes through a prism, it's split into different colors. This is known as dispersion. We know that light bends when it travels from one medium to the other because of a change in speed of light. So the different colors of light actually bends towards or away from the normal through different angles when entering and leaving the prism. So let's look at a simulation. So go to prisms over here and include a prism. Change this to white light, and we can see that as it exits the prism, you'll see the rainbow colors. So how does this work? Now notice that when it enters it at 90 degrees, it won't actually bend, it will just travel in a straight line. Okay, but if I have an angle, let me just angle my protractor accordingly. Okay, you can see that the angle of incidence is about 45, but when it goes into the light prism, it's about 30. So we can say it bends towards the normal, right? And as it exits, it bends away from the normal, like so. Like so. So we see that it enters at about 35, and it exits at about 60 something. Yeah. So this shows that it has been quite very much away from normal. So which one bends more? If you look here, we can see that the extent to which the purple light bends. So this is the original path of white light. Let me just draw with white pen. This is the straight line. So you can see that they all bent, right? But which one bent the most? Red is here, but purple is over there. So we can see that this is the difference, whereas this is the difference. So which one bent the most? The least would be red. The most would be purple. And this one is just for you to play lah. Okay, just play this and see whether it works. Last portion, what's the impact of application of radiation on society and our environment? So the impact of light brought by technology has both beneficial and harmful effects on society and environment. The thing is that the light that we can see is in a very narrow spectrum known as the visible light spectrum. I'm sure you've heard of something called infrared light, ultraviolet light. So, let me see. I think this is written in your textbook, so you can look at your textbook and read up on this. There's a very narrow range known as your visible light. To its left, there is the infrared light, and to its right, there is ultraviolet light. Ultraviolet light, which makes sense because there's infrared, right? Red, orange, yellow, green, blue. Okay, don't ask me what's the difference between indigo and violet. I still haven't figured it out yet. Okay, then after that, you move to ultraviolet. So before red, it was infrared. Okay, so that's how you can remember lah. So electromagnetic radiation on the whole has both beneficial and harmful effects. One example that is easy for you to understand is that city lights can improve night visibility, but they cause light pollution. pollution. Now, this is an issue, especially for big cities, or very busy cities like Singapore, Hong Kong. Some of these cities have very serious light pollution, and we are unable to observe the night sky. Other than this frivolous reason of human beings being unable to observe the night sky, it also causes disorientation of birds, and this also releases a lot of energy in the air. Okay, because you use up electrical energy to power up the lights. However, there's of course good applications of these electromagnetic waves. So our ultraviolet radiation is actually used in thermal imaging cameras. So this was used back when we had SARS, and more recently when we had COVID. So if you pass certain airports, you will see that there's this infrared thermal cameras that will try and screen people for fever. It is also what is typically used in your remote control to on your TV. There's this red color button. There's this red color light right at the front of your remote control. So take a look at that. You probably can find it. Ultraviolet radiation is what we have from the sun. So ultraviolet radiation is good because it can help to produce vitamin D in our body, and it helps in disinfecting and sterilizing equipment. However, too much exposure to UV light actually causes skin cancer, and that's also the reason why it's important for us to wear sunblock. For visible light, we, not us, but plants use it for photosynthesis, and of course it helps us to see colors. And so, the harmful effect is that it causes chemical change in some materials. And of course, it causes light pollution. This was the image I was trying to find. Yes, you see that visible light takes up part of the electromagnetic spectrum. And infrared comes just before red. Ultraviolet comes just after violet. There are also a lot more useful types of electromagnetic radiation, such as X-ray, which you know that is used to image your body, what's inside our bodies. Radio waves and microwaves, these are what we use in our daily lives, right? Radio to broadcast signals, microwaves for us to heat up our food. Gamma rays is something that you may not have heard of before. That's because it's quite dangerous, but it can also be used for good use in medicine for killing cancer cells. So in summary, you can try out this activity to recap reflection, refraction, and dispersion. Okay, these are some fun puzzles for you to play. Okay, and I would like you to complete the homework that I will be assigning you on Google Classroom. That's all. Thank you, class.